Good evening, children. I hope you people have watched my previous videos on similar triangles. Today I am going to start a new topic, locus. It is very important topic from academic point of view. I have divided locus in three parts, part 1, part 2 and part 3. Today we are going to discuss the first part in details, which includes the basic concept and definition and some examples also. Okay. Locus is the path of moving point P according to a given condition of geometry. It is important thing. Condition of geometry. That means any geometrical condition should be followed by that moving point. Geometrical condition. Otherwise, the point any at random way it is moving like this, don't have there any feature. That is not locus. Locus, that means under certain condition. Under certain condition it is moving like this. Then it is the locus. I have explained there some examples. Through this example it will be more clear. First example is, let AB is a fixed point. AB is A and B, 2 points joining both point. AB is a fixed line. Then the locus of moving points P at a constant distance D from fixed line AB is the pair of parallel lines on both side above the line and below the line. That means we have to draw the locus of the point P at equidistant from each and every point of AB. That means it is like this. The locus movement of point P is each and every point is equidistant from AB. Then this condition is like this. And locus of point P above the line AB and below also it is possible. So of each and every point is equidistant from AB, above the line AB and below the line AB. That means this both lines are parallel to each other and all three are parallel to each other. Locus of the moving point P equidistant from the given line AB, that means above the line AB at equal distance, this line and this one also above the line AB and below the line AB, locus of the point P satisfies all condition of geometry. In the same way, second number example I have taken. Suppose two parallel lines M and N are 4 cm or 6 cm apart. I have taken suppose 4 cm apart. M and N, two lines. The locus of a point which is equidistant from both the given lines is parallel to the both given line. Suppose I have to draw one locus of moving point P equidistant from both given line, then we will draw from here and each and every point equidistant from both given line. Both distance between both is 4 cm. That means there is 2 cm, 2 cm. Each and every point satisfy the condition of geometry. That means it is 2 cm, up also 2 cm. In this way, the locus of the point P is moving like this, is equidistant from given line. Third example I am explaining of a circle. The locus of a point P moving in a plane such that each and every point of P is equidistant from a fixed point O with center O and radius R. That is the complete definition of circle also. Just like suppose example O is fixed. Now the locus of the point P, locus of the point P such that each and every point of the locus, that means path, is at equidistant. Just like suppose this distance is R, then at equidistance from the O is a circle. That means each and every point of the path satisfy the certain condition of geometry. Fourth example I have taken. AB is a line and P is point. Suppose a lot of circles of different radii above the line AB and below the line AB I have supposed, but condition is all the circles touching at the point P given on line AB. Then the locus of all centers of all those circles are perpendicular to the AB. At point P, which is given on line AB. Now fifth number example is the locus of a point which is equidistant from two fixed points is the perpendicular bisector of the line joining the both points A and B. Just like suppose there are 2 points are given A, B, 2 points joining A, B, it is a line segment. Then locus of all the points which are equidistant from both the points. First find out all that points which are equidistant, are at equal distance, equidistant from both the points. We can say there are a lot of isosceles triangle, formation of a lot of isosceles triangle. Then locus of all the points which are equidistant from both point A and B is perpendicular bisector of the given line segment AB, is perpendicular bisector. That means under geometrical condition is all definition of locus under geometrical condition I am explaining. Now sixth example is the locus of, sixth example I am giving for a wheel. Suppose a wheel is moving on the road. Your bicycle is moving on the road. Then the center in each steps of wheel is like this. Then the locus of all the centers of the wheel is parallel to the road, because the each and every point of the locus are at equidistance, because radius always perpendicular to the tangent. In this way I explained 6 examples for locus. I hope you understood better the concept of locus.